Hello everyone! Let's solve this problem, which asks us to propose a structure for the compound with the following spectra. The first thing we need to do is to make some conclusions. Let's start with the mass spectrum. The peaks emphasized in this red box are the 78 mass to charge ratio peak and the 80 mass to charge ratio peak. Whenever we compare two peaks like this that are 2 peaks apart, we need to compare the relative heights to understand what atom we have in our compound. In the case of M+2 peaks, we know that if they are very small, it is most likely due to oxygen 18 isotopes or having 2 heavy isotopes like carbon 13 and hydrogen 2 in one molecule. However, this is very unlikely. Finally, if the M2 peak is not relatively very small, it means our compound either contains a chlorine or bromine atom. We know we have a chlorine atom if M+2 is 1/3 the size of M. And we can tell we have a bromine atom if M+2 is approximately the same height as M. After eyeballing it, we can confirm the 80 mass to charge ratio is 1/3 the size of M, which is the molecular mass of the compound. So let's write down somewhere that we have determined the molecular mass of our compound is going to be 78 atomic mass units. Great. And let's also write down what else we know, which is that we have a chlorine atom because the peak at 80 mass to charge is 1/3 the height of M at 78 mass to charge ratio. So we know we have a chlorine atom, and chlorine atom will weigh 35 atomic mass units. Great. Other significant peaks that further prove we have a chlorine atom would be the peaks at 63 mass to charge ratio and 65 mass to charge ratio, because the peak at 65 mass to charge is 1/3 the height of the peak at 65 mass to charge ratio. So we can already eliminate answer choices B and D as they both do not include a chlorine atom. Now let's move on to the infrared spectrum. For this, I highly recommend you have an infrared spectroscopy absorption table at hand for reference. A strong band is seen around 1800 inverse centimeters. Recall that a band around 1780 to 1650 inverse centimeters indicates a carbonyl carbon double bonded to oxygen stretch. When chlorine is also present in a molecule, a band around 1800 inverse centimeters, as I have highlighted here in pink, is most likely due to an acid chloride. An absence of a peak around 1600 inverse centimeters, which would be around here, indicates to us that we have an acid chloride as well. Because if there was a peak in this 1600 inverse centimeter region, it would indicate a carbon-carbon double bond, which we do not have. So now let's erase the chlorine here under our known section and replace it with more that we know, which is that we have an acid chloride functional group in our compound. So let's just draw the general structure of an acid chloride. The general structure of an acid chloride is a carbon double bonded to oxygen and also bonded to a chlorine atom and a side group, which we do not know, and need to determine. So finally, all that's left to do is to determine this R side chain. To do this, we must subtract the mass of this COCl group from the mass of our compound, which is 78. So again, the mass of our compound is 78 atomic mass units, and we need to just subtract this group circled in red here. So the carbon atom is going to weigh 12 atomic mass units, oxygen will weigh 16, and chlorine weighs 35. And that will give us 63 atomic mass units, which will be the weight of this group circled in red. Great. So now that we've done that, we need to subtract this group from our total compound weight, which is 70 atomic mass units. When we do this, we get 15 atomic mass units. So this is how much our entire side group will weigh. If we subtracted one carbon, which weighs 12 atomic mass units, we would have 3 atomic mass units left over, which checks out because these account for the 3 hydrogens bonded to this carbon. So finally, we have concluded that our compound with the spectra is a carbon double bonded to oxygen, also bonded to chlorine, and we have just determined that our R, our side group, is a methyl, so CH3. This is our final answer, and it is known as acetyl chloride. We can eliminate answer choice A confidently, as going back to the IR spectra, it does not include the very strong and broad peak around 3,300 to 3,400 inverse centimeters, which is distinctive to the OH stretching in alcohols. But we don't have that, so A is not correct. This is our correct answer choice, which is C, and it is called acetyl chloride. Thank you very much for your time and attention. Have a great day.